Ooh, how do you calculate the Ka of an acid if you're given the pH at a particular concentration? Well, do you even remember what the Ka stands for? It's the equilibrium constant for the breakup of the acid. If HClO broke up in solution, it would make an H plus ion, and it would provide a ClO minus ion. I believe that's the hypochlorite ion. The Ka is the value of the equilibrium expression, which is the concentration of each of the products of the reaction divided by the concentration of the reactants. In this case, it's just HClO, and these are concentrations at equilibrium. So, who cares? I care. Many people care, and here's why. Because if you use an ice table to figure out the concentration of each of these, what you'll find is that, let me just set this up, HClO breaks up to give H plus and ClO minus. HClO initially is 0.1, and these are nothing. HClO, a little bit of it breaks up and disappears. Some of these appear in its place. So the equilibrium expressions are 0.1 minus x, x, and x. What is x, though? And here's where this question differs from the regular kinds of questions where you're given a Ka and you're asked to find the pH. Because you're given the pH, you already know what the concentration of H plus is. The way you can get the concentration of H plus is that it's 10 to the power of the negative pH. In this case, 10 to the power of negative 4.23. And on my calculator, the way I'm going to find that out is to actually type 10, my little to the power button, of negative 4.23. I get 5.89 times 10 to the negative 5. 5.89 times 10 to the negative 5. So that is my x, because the concentration of H plus is x. And this is where things get awesome, because they've already told us that Ka is the concentration of H plus. Oh, well that's 5.89 times 10 to the negative 5, isn't it? Times the concentration of ClO minus. Oh, well that's 5.89 times 10 to the negative 5 as well, isn't it? And the concentration of HClO is 0.1 minus 5.89 times 10 to the negative 3, isn't it? What you'll find is that this part doesn't even really matter. Oh, first of all, it's a 5. This part doesn't even really matter because it's so small relative to the 0.1. But you know what? I'm going to type it in anyways. So, the Ka can be calculated by taking 5.89 times 10 to the power of negative 5 times 5.89 times 10 to the power of negative 5. Divided by, and I'm going to put this whole thing in brackets, 0.1 minus 5.89 times 10 to the power of negative 5. And the bracket, done. I get 3.47 times 10 to the power of negative 8. 3.47 times 10 to the negative 8. A completely legitimate value for the Ka of a weak acid. And that's how you do it. Best of luck.